Hi everyone, I'm Ned Jamieson and I'm an educational design architect at A Cloud Guru, a cloud skills training provider. Part of my role involves looking at what technologies our customers and industry more broadly are investing in, and that's the perspective I'm bringing in this session. That involves looking at what businesses have planned and what focus areas we'll need to address so that industry has the training available for their workforce to achieve their tech strategic objectives moving forward. I've spent about 15 years in the tech sphere in a variety of roles from development and architecture through to strategy. Probably most relevant here though, I've been involved in many production projects involving Lambda. So that's me, and today I'm going to talk about serverless in an AWS context. I'd like to set some expectations from the outset. This session is targeted at those who don't necessarily live and breathe Lambda, but if you are someone who does this in your day job, stick around because there might be something that you're not aware of. So let's get into it. The session has two main areas of focus. Firstly, what are the major considerations of industry when it comes to serverless generally at the moment? And secondly, and this is AWS specific, what technologies and features are we hearing are having an impact on serverless implementations this year? So first we'll look at the big picture considerations. At A Cloud Guru, when we hear from our customers and when we look at industry reports, a really powerful message we're hearing is that a change is happening. And that is, as serverless technologies and offerings mature, as they continue to flesh out, and we'll go into some of these new AWS developments in a few minutes, there is an increasing understanding that we're well past talking about using serverless approaches for prototypes. Now it's all about serverless in production. And when we're talking about production, it becomes far more about the business case than it ever has before. So right now, at the enterprise end of the market, some of the questions that are being asked are, how much control do we want to give the cloud vendor? Do our usage patterns or tech strategy align with re-architecting our applications to work on a functions as a service or a serverless container model? Does reducing the cost of having idle server time make sense given the potentially large costs associated with re-architecting? And in many of these cases, the answer will be yes. But that's sort of the point, that we're now in a situation where it well and truly is an appropriate option for a wide range of production workloads, but it may not always be an appropriate option for the business itself. The next consideration that we're seeing is around vendor lock-in. We are absolutely seeing the adoption of cloud agnostic frameworks and approaches as they continue to grow. So serverless framework, Terraform, and I'll touch on these a little bit later. What gets lost in that though is that for commercial reasons, moving to another cloud vendor is just not on the cards for most businesses. You may want to limit your exposure or have redundancy or have specific workload requirements, but generally speaking, the additional costs in either lock-in or maintaining a plan B make it unrealistic on the ground for more mature organizations at this point in time. Startups, of course, are an exception to this. The third consideration is around how much control an organization wants to hand over. In a traditional web app, you have pretty thorough control over the application stack. You can set up monitoring for requests that include data like time to execute all relevant server-side calls, full page render times, or log analysis. And using that information, you can rapidly find bottlenecks as you have visibility over how that stack operates, how long things typically take, and so on. But moving to serverless or to a serverless architecture means, of course, that you don't have that same level of control. And monitoring can be done, but it's more expensive as a result of the distributed nature of the architecture. And you're likely to run into issues like incomplete tracing for exceptions or even performance hits in metric tracking. There are native and third-party tools that help fill this gap, but one of the key considerations at an industry level when thinking about serverless adoption is how much control are you prepared to give up to your cloud vendor or a third party? And this will very much continue to be a concern. Now let's get a bit more AWS specific. What are those technologies and features that will or are having an impact on the serverless landscape? For those that live and breathe serverless, you're going to be aware of these because there's a good chance you jumped on them the day they were released in preview. For those that don't live serverlessly, I'm assuming that you may not have heard of them, so I'll explain what they are and the significance of them. Amazon EventBridge is an event bus, meaning it provides a channel where events can be communicated without being aware of other services creating events or listening to events in the channel. If you're familiar with CloudWatch events, it encompasses a lot of that functionality with a whole bunch of extra things. All of this means that you can coordinate your events much better because you can replace services at either end, as long as the structure or schema is preserved. By using it, you're able to modularize your architecture that much more. One of the biggest differences between Amazon EventBridge and CloudWatch events, and one of the key parts of this that really helps with adoption of it, is that it works with partner event sources like Auth0, BuildKite, Zendesk, Datadog, and so on. I think many of us have been in that situation where we needed to integrate third-party events into a serverless pipeline. And what we've discovered is that the data we need sent is walled off in that third-party system, and it has to be configured for each event. This really helps address that situation by centralizing it and integrating it with partners so that we don't have to worry about fiddling around with webhooks. This means that we can also reduce risks associated with security or network issues and the error handling around them. So we've got those events passing through, and what we can do is we can set rules on incoming events to send or redirect them to different destinations or targets. These different targets might be AWS services or third-party SaaS integrations. What this also allows us to do is to introduce branching logic, because not everything has to be handled in the same way. How does this differ from something else we might use? Well, SNS is scalable and it's reliable, but what SNS is missing is that filtering essentially based on the content and context, and it doesn't ensure that the order is preserved. Whereas, say, Kinesis Streams does preserve the order, but they don't automatically scale. But all of this depends upon understanding the structure of data. The EventBridge schema registry that has been released helps with this because it lets us store all of our event schemas in a central spot. And then we can reference and generate code bindings for those through our development environments and frameworks. And here's the thing that's huge about it. It automatically detects and stores schemas for the events. It does require a little bit of work to get the fields correct, but it takes a lot of the time and effort out of the process. So it's very big at the moment. Another new feature is provision concurrency for Lambda functions. If you've used Lambda in production, you know exactly why you'd want this. If you haven't, I'll give you a quick recap. When you've just deployed a new function or your function hasn't been invoked for a while, your functions will be cold. That means that when an event triggers the function, a new environment will have to be initialized or initiated. The runtime configured, your code and its dependencies imported, and then your code actually has to be executed. This can take anywhere from 50 milliseconds to much, much longer. However, after it's running, the particular environment stays available, waiting for a new job until it's waited long enough and it's automatically removed. If a job does come in, it's ready to go and it doesn't need that starting time. The way we've previously handled this cold start issue was to keep the lambdas warm. And it was a bit complicated. You'd essentially make periodic requests to the function to keep it alive, but then you'd have to include handling for determining whether it was a real request or not. So the new approach is provisioned concurrency. The way this works is that we set a value for how many provisioned instances we want for a particular function, and Lambda will make sure that it always has that number of warmed instances ready. Why this is important is that it gives organizations certainty in that unknown delay before functions run. And this is particularly important for those functions that are customer facing or synchronous. It can be configured with application autoscaling, and it works with a whole range of triggers. For those that aren't aware, AWS Step Functions is an orchestrator that helps with complicated workflows. This makes it really easy to build systems that have multiple steps. So when we build a workflow, or maybe we have multiple tasks that need to be coordinated, Step Functions does this for us. A situation where you'd use it might be sequential batch processing, where you're performing different actions based upon the outcome of earlier steps. Or another use case might be one that requires manual intervention. So a human signing off on something before a whole series of actions are performed, that sort of thing. Or another option that is talked about a bit is branching a task to different architectures. So maybe you'd send it to on-prem, or it could be a function for whatever reason. So there's two updates that have been really well received for step functions: dynamic parallelism and express workflows. So what is dynamic parallelism? Well, it allows us to enhance the parallel state with the use of what's called a map. Previously, the parallel state could be used to execute in parallel a fixed number of branches, which were defined in the state machine. But now we can do that dynamically. This can be implemented through fan-out or scatter-gather approaches. Fan-out is applied when delivering a message to a number of destinations. So you might want to use it for batch data processing when you're getting a group of messages from Amazon SQS and then sending each message to a separate Lambda function for processing. Or the scatter-gather approach broadcasts a single message to multiple destinations. So that's the scatter stage, and then aggregates the responses, which is the gather stage, to be used in the next step. This can be useful in processing things like video files in parts and then pulling them all back together at a final stage. Along the lines of this scaling was the introduction of express workflows. Step functions have a limit of around 2,000 execution starts per second as a limit, which is absolutely fine for most use cases, but what happens when you need to manage workflows with much more data in a cost-effective way? Well, Express Workflows aims to solve this. They're designed designed for large volume data ingestion and can start over 100,000 executions per second. Of course, there's limitations to this. They're limited to 5 minutes per execution, compared with the usual of up to a year. So really, Express Workflows are intended for short duration, synchronous processes where there aren't supporting callbacks or activities. Which brings us to how serverless is being implemented. And this really depends on the size of the organization, the maturity of the code base, and whether vendor agnostic code is desirable enough that you'd put the extra energy into maintaining it. What we've seen is that virtually no one manually configures their Lambdas these days, or at least is prepared to admit it. And the reasons for that are pretty obvious. It's hard to track changes or replicate what you've done. Undoing changes is really tricky. You can't easily explain to others what you've done, and there's some issues with resource cleanup. For those organizations that are heavily in the AWS space, we're seeing a clear preference for AWS Serverless Application Model, or SAM, and CloudFormation, with SAM being an abstraction on top of CloudFormation. Serverless framework continues to be popular, but what we've heard is that it is considered to be less preferable for mature enterprise environments. It has a great plugin functionality and it works for a lot of startups. And of course, it's vendor agnostic, but it just doesn't give that same level of control because it's an abstraction layer and it's not easy to manage additional infrastructure or dependencies. For those that use Terraform, and there are a lot of organizations out there that do, or are looking for an agnostic solution, we're seeing a preference and a lot of interest for that when used in conjunction with CloudFormation and SAM or serverless framework. The downside here is that if you're not using SAM or serverless framework, you lose out on the log tailing and local environments, which can really speed up development. Until EFS support was added, a Lambda function was limited to 512 megabytes of temp storage, and about half that for deployment package sizes. This was fine for most users, but it meant that processing large data sets was very difficult, and loading additional libraries in our code required all sorts of wrangling if it were even possible at all. What this new EFS support means is that you now have the ability to load multi-gigabyte files and use them in your functions. Machine learning being a really obvious use case here. The EFS in Lambda support also allows you to share state between concurrent executions of a function or even multiple functions. And you may well say, can't I just do this in S3? And in many cases, you can with similar latency. But S3 has a different pricing model, and that needs to be weighed up based on your specific use case. Realistically, this may mean that we will see lazy Lambda implementations that throw everything on the file system because it's just easier to manage. But there's often faster and better audited alternatives on AWS, so that shouldn't be the dominant approach, we don't think. There are issues. It's slower than the local file system, and there's latency associated with cold starts, but this can be mitigated if provisioned concurrency is used, so bear that in mind. Now, you're not going to see cost savings on this particular one unless you're running decent production workloads, but there are other benefits. The introduction of the HTTP APIs for API Gateway provides some extra functionality, improved performance, and an easier setup than previously for applications where Lambda proxies and HTTP proxy APIs are used. And they sit alongside the existing REST APIs and WebSocket APIs. They do miss some of the authorizer functionality you'll find in the REST API, but they add native OpenID Connect and OAuth 2.0 authorization. You can use custom domain names, but not wildcard subdomains, and they come with built-in support for cores and automatic deployments. Some of the other functionality you lose if you adopt them is caching or caching, however you want to say it, X-ray support, usage plans, JSON schema validation, and a few other things. The cost benefits are pretty significant, sitting at more than 70% reduction compared with REST APIs. And on the performance front, they reduce latency by about 60% compared with REST APIs. So they're likely to become a part of a lot of serverless deployments. Up until now, you might have thought, okay, is this only focused on functions? What about containers? And part of the reason for that is that up until about 7 months ago, Fargate only supported ECS, so we didn't see a lot of demand for it. What we're seeing now, though, is that with the EKS pod support on Fargate, along with the continued adoption of Kubernetes across the industry, there's far more interest in this from the bigger end of town. On the ECS front, the introduction of Fargate Spot, which brings cost savings for those applications with fault tolerance, means that Fargate has become a far more appealing option for jobs that require large-scale batch processing, and this is definitely one to watch over the next year. Until recently, DynamoDB has been the only real option for a serverless database that was ready for production environments. But the main issue has been, for a lot of businesses, it's been vendor lock-in. This is especially true for databases. So the data architectures haven't necessarily been serverless for many organizations. So they might have used Aurora Serverless or MongoDB because they're supported by open source APIs. rather than going down the DynamoDB route. The problem has been that they're not particularly fast or scalable. And this is where Amazon Key Spaces for Apache Cassandra come in. It's a scalable, highly available, managed Apache Cassandra compatible database service. And part of this scalability comes because each node in Cassandra can serve requests directly. So it's pretty cool. And because Cassandra is an open source database system, it can be deployed anywhere, even on-prem. This means that migrating an application that relies on Cassandra is so much easier than doing the same thing in the proprietary DynamoDB. So this is definitely one to look out for, and it's one that industry are generally pretty excited about. So in summary, at an industry level, it's about the business case, increasingly less so about the tech. Vendor dependency will continue even though vendor agnostic implementations are desirable. And it's about operational awareness and being very, very considered around what you want control over and visibility into. At a technology and feature level, EventBridge really supercharges events. Provision concurrency for Lambda addresses that issue around cold starts. Step functions are now so much more scalable at the bigger end of the scheme. IAC approaches are increasingly vital, and there's a variety of ways that you can do it, but they are very, very big at the moment. EFS for Lambda provides expanded use cases. API Gateway is cheaper and quicker for HTTP APIs. EKS support on Fargate is really quite exciting on the serverless container front, and Amazon Key Spaces for Apache Cassandra open up the idea of moving to serverless data models, which have previously been somewhat ignored. And that's it. Thank you for listening. If any of these industry trends or newer features align with what you're seeing, or even if they don't, we're very interested in hearing your perspective. So please feel free to reach out via email or LinkedIn. And I look forward to the Q&A coming up next. Thanks.